Hi, this is Philip in the Austin, Texas office, and I'd like to take a few minutes to look at SOLIDWORKS plastics in SOLIDWORKS 2017. Now, if you're not a simulation user, you'll be happy to know that, like the rest of simulation, I have the options to not load this plastic data when the part is open, so it won't affect any performance anywhere else. In fact, I can use this in configurations, even derived configurations, so I can keep my changes and my simulation changes specific to my configurations and not affect the rest of manufacturing. Here I actually have a setup already made, but I'm going to make a new one, and what I'll do is just copy my previous design. What SOLIDWORKS is doing right now is creating a second SOLIDWORKS plastic simulation setup that looks identical to the first. So if I just want to change one parameter, maybe try out a different material, I only have to change one setting and I'm ready to run. In fact, I could go a little bit further than that. I can even design the runner and cooling system inside of plastic simulation. I can do this by using a wizard or making my own sketches, specifying the diameters and even using draft angles. Once I'm happy with the mold, the cavity, and even my runner design, I can move forward to the mesh, and I want to point out that the meshing in plastics is the most advanced of any simulation process. I can use a specific triangle design, an automatic transition so I have geometry changes like a small fillet, I automatically get a smaller mesh size. I can control the gradation or how fast that automatic change happens, use a combination of something I've assigned or in between. This could be a tetrahedral mesh, a hexahedral mesh. You even have individual control over the different mesh points. This could be a solid or shell mesh, but in fact, I've set this up ahead of time, so I'm just going to switch configurations to one where I actually run so we can take a quick look at some of the results. Here you can see the type of mesh I'm using, where I have some assigned triangle sizes as well as those automatic transitions. And if I jump into the results, we can look at some of the animations or qualitative results that come out. Looking at my fill time, I always get the maximum at the top of my legend, so even if I change my color chart, I'll always remember where the max is. I can slow down this animation, and you can take a look at the effect of a gate I've used on my center injection location. This gate doesn't open up and allow the fill until 30% of my part is filled up. This gives me a bit of control over where these frontal flow boundaries actually meet each other, which would create a weld line. This could be a structural or maybe just aesthetic defect, and I can view those as well with a color-coded chart. There's a lot of great qualitative components that come out of this, but of course we all want to know the hard numbers, and XY plots is a great way to do that. Let's take a quick look at part mass. What we can see is the effect of my injection cycle, whether that be gates in the initial fill or even the flow and pack cycle. See what effect it has on my part mass over the entire cycle. As you can see, there's a lot of great information that comes out of SOLIDWORKS Plastics in 2017, whether you're just a part designer or you actually own the injection mold machine yourself.